This lesson is from Mrs. Cucci's College Now PreCaculus class. We're on lesson 7.1b. This is Mr. Saloom. So let's open up our notebooks and get started. Alright, so last time we were talking about the law of sines, and we solved when we had two angles on one side and we solved for the other side. This time we're going to take that, we're going to go the other way. We're going to be given two sides and an angle, and we're going to solve for the other angle. There's three different cases that are going to be able to happen here. So this is going to be solving for an angle. Using law sines. So we're going to have three cases. Let's take a look at case one. This is the most basic case, and the case that we kind of hope will happen. We have a triangle. We have triangle X, Z, Y, and remember our sides are labeled in lowercase letters across from the angles. Okay, and we know that angle X is 39.7 degrees. And we don't know angle Y or angle Z. That's what we're going to be trying to find here. But they do give us that side Y is 9.8. And they tell us that side X is 23.5. Okay, so the first thing we're going to do is solve for angle Y. So remember our law signs, we're going to have our side Y over sine of angle Y equals, and now we have to use the one we have both for, which in this case is our x's, so we have little x over sine of x. Okay, we can plug in what we know. We know side Y is 9.8. We don't know what angle Y is. That's what we're looking to find out. We do know that side X is 23.5. And that's going to be over the sine of X, which is 39.7. So we're going to solve for sine Y by cross multiplying. Sine Y is 23.5. Equals 9.8 sine 39.7. So for sine of Y, I get sine Y equals 0.2664. Okay, so now by taking, to find the angle, we need to use the inverse sign. So sine inverse of 0.2664. When you plug it into your calculator, it's going to give you 15.4 degrees. However, because remember our laws about sine, sine is positive in both quadrants 1 and quadrant 2. So our other angle it's going to come out to is 164.6 degrees. And now if you remember, this is our ambiguous case. So if you take a look, we already have an angle of 39.7. If we take 39.7 and add it to 15.4, that number is less than 180, so we're okay, we still have room for a third angle. However, 39.7 plus 164.6 is greater than 180. Greater than 180. So we don't have room for a third angle. So this answer is not a solution. We are left with just one solution, 15.4 degrees for angle Y. So I'll come back up here and fill that in. Angle Y is 15.4 degrees. Let's solve for angle Z now. So to solve for angle Z, we're going to use our law signs again. This time we're going to use Z's, of course. And I always like to use the one that they give, the given one, sine x over x. So we know our side Z is what we're looking for. We know, we're solving for our side Z. For angle Z. Yeah. Alright guys, so now that we've found, before we do this, now that we've found our Y, angle Y, we could do law of sines to find our angle Z, but we also could use our rules about triangles. Since we know that the sum of the angles is going to be 180, 180 has to equal 39.7 plus 15.4 plus our angle Z, big Z, big Z. And when you solve that, it's going to come out that 124.9 equals our angle Z. Once again, we could have done this using law signs, but it's going to be simpler if you already have two angles to find your third angle just by doing that. We can now solve for our side Z, which is the last thing in our triangle that we don't know. And this is just like last time. We're looking for our side Z. We're going to put that over the sine of our angle Z, which we just calculated to be 124.9. And we're going to use side X, 23.5, all over the sine of big X, which is 39.7. Cross multiply and we're going to get Z equals 23.5 sine of 124.9 all over the sine 39.7. And so the last piece of a triangle, Z is going to be 30.2. Okay, let's move on to case 2. And in this case, you see something kind of special happen. So here we have in triangle Q, R, S, little q, so that's a side, is equal to 15. Little r, which is side r, it's going to be 28. And big Q, so angle Q, equals 43.6 degrees. And we want to know what angle R is. So we can use the law of sines to do this. We have R over the sine of big R equals Q over the sine of Q. And you guys are going to see why I don't want to draw the picture and spoil the fun for you in a second. So we plug in what we know. We know R is 28. We're looking for the sine of R. We're looking for angle R. Side Q, 15. Sine of angle Q, sine of 43.6 degrees. And so we're going to cross multiply and we get 15 sine R equals 28 sine 43.6 divided by 15. Come on. And we get that the sine of R equals, or is approximately equal to 1.2873. And we should have some lights going off in our head here. Sine, if you remember, can't be greater than 1. So since sine is bigger than 1, this actually has no solutions. Okay. And the reason being, the picture that I didn't want to spoil by showing this first. Q. Here's our angle R right here. Notice how this side Q, across from angle Q, is not long enough to reach here and actually make a triangle. We don't have a triangle. There is no angle R, and that's why sine is greater than 1 and doesn't exist. Okay, moving on to case 3. We have a triangle ABC, and we know that side little c is 20, side little b is 15. We don't know side little a, but we do know that angle B is 29 degrees. And we would like to solve for angle C. So we're going to use law of sines to do that. My B is the one where I'm given both, so I'm going to use B over the sine of B. Equals C all over the sine of C. Plug in what I know, 15. All over the sine of B. Sine of B we know is sine of 29 equals side C is 20, and we're looking for sine of C. Okay, so we cross multiply 15 sine C equals 20 sine 29 degrees. Divide by 15, plug it in, and we end up getting sine C equals 0.64. Okay, so we do our, I'm going to come up here. We're going to do our sine inverse. Of 0.6464. and that comes out to 40 degrees. But remember, that's only one quadrant. Sine is positive in quadrant 1 and quadrant 2. And in 40 degrees, if we go in quadrant 2, it's going to be 140 degree. 40 degree reference angle in quadrant 2 is 140 degree angle. And this solution, these now, if we check them, 40 degrees, we already had an angle of 29. That's still way less than 180. And 140 plus 29 is less than 180. So we actually have two possible triangles that could come out of this. Solving for the third angle, let's try the first triangle. 180 minus 29 plus 40. That's going to come out to 111 degrees. 111. And this is our angle, other angle we need here, angle A. Whoa. Sorry, guys. Too far. Okay. So our C could be either 40 or 140. Angle A, when C is 40, is 111. When C is 140 degrees, angle A is 11 degrees. Angle A is 11 degrees. And now, of course, we have two different scenarios for side A. Trying to find A over the sine of A. Equals. And now, you can't use the given one. You're going to have to use the one that has two. You're going to have to use C over the sine of C. Because you have two different scenarios and they each need to be reflected. In one scenario, you're going to plug in, of course, you're looking for your A, your sine of A. Your A is 111 degrees, your angle A. We're doing the first case. C. Come on. C is 15. And the sine of 29, we're using the first case, remember? And when you do that out, with your cross multiply, you're going to get side A is approximately equal to 29. And remember, this 29 is a lot different than this 29 degrees. We now have the other case where we have A over sine of A equals C over sine of C. In this case, we still have A. Now, instead of this, our angle A is going to be 11 degrees. Our side C is still 15. And side C is still sine of 29. But this time, A is going to be approximately equal to 6 when you do out the cross multiplication. So I'll just come back up here. A could be, in the first case, A was 29, and in the second case, A was 6. We have two different triangles because we had two different angles for angle C. And that's all the time we have for today. We will pick this up tomorrow with area of the triangle.